Hello, hello. Characters A and B. You can delete any number of characters S to make S balanced. S is balanced if there is no pair of indices ij and S of I is equals to B and S of j is equals to A. Hmm. There are only two characters A and B. So B should not be present first. If I remove this, okay, you can either remove 0 index position 0, 1, 2, 3, 4, 5, 6 or 0, 1, 2, 3 and 6. Okay, how would we solve this problem? So B A B B A B. Hmm. If we go from here and count the number of A's, okay, I am thinking stack approach where this gets into stack, this gets into stack, this gets into stack, but if the top of the stack is B and the next element is not attempting gate,
Hmm.
I don't want to attempt gate. I can attempt, I don't want to get into mtech. See Gate 2026. IT Guwahati. Application is done. Now. Wow, very nice website.
Hmm.
Lol. Tomorrow exam. It's even today. Today, tomorrow, and then next week. Announcement is March. I can do data science. Computer science नहीं होगा मेरे से. Computer science is too much of this, 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 this. Oh my god, this too. Wow, it's lessa. Oh yeah, less. Are you attempting? Yup. All the best, man. Do well. We can sit and try. Uh, Question paper, pattern, test papers. Various test papers. Test papers. This is syllabus. Rec. Mock test links. I'm doing operating system since 3 days. Makes sense. What the heck? CSE or data science? CSE operating system is not there in. Just click out, click in. Okay, I got this paper. IT Roorkee. Last year paper was pretty easy. It seems I don't know what will be the situation of this year. Six. Okay, let's see. Suppose a program is running. You are writing for CSE only now. This is CSE paper. Okay. Suppose a program is running on non-pipelined single processor computer system. The computer is connected to an external device that can interrupt the processor asynchronously. The processor needs to execute the interrupt service routine to serve this interrupt. The following steps are taken by the processor. The processor saves the content of the program counter. The program counter is loaded with the start of address. The processor finishes a present instruction. Which of the following sequences is correct? Okay. based on intuition. Current, present, present instructions finishes the present instructions. Will it needs to execute? Come on, Karthik, you can do this. What's the answer? These are the options: 312, 123, 321, 132. Operating systems are. What the heck? I'm guessing it won't finish the present instruction. It will save the content of the program counter. The program counter is it's 123. You're saying A 312. Let's ask short GPT or key will be there now. Key is not there. Huh? Answer keys. This is CS1 question. Ooh, A. Processor finishes the present instruction. Why does it finish though? It waits for the present instruction to finish. Okay, nice question. Which one of the following statements is false regarding the symbol table? Symbol table is responsible for keeping track of scope of variables. Non-pipelined. Ah, one after another. Okay. Pipelined is one after another, no? I don't know. Symbol table is responsible for keeping track of scope of variables. Can be implemented using the binary search tree. Is not required after parsing phase. Is created during is false. I'm guessing C. Binary search tree. I think you can implement it. Yeah, C. Question 12 C. I got my mouse. Which one of the following techniques is used in compiler code optimization? Uses live variable analysis. Runtime function call, register assignment to values, strength reduction, constant folding. Constant folding, I think that is familiar. Compiler code optimization uses live variable analysis. Oh my god. Come on, Karthik. You can do it. Question has answer in it. Which one of the following is compiler code optimization used while live variable analysis? Register assignment to variables. Huh. Okay. Damn. Good, good. Consider a demand paging memory management system with 32-bit logical address, 20-bit physical address, and page size of 2048. Assuming that the memory byte is addressable, what is the maximum number of entries in the page table? Paging memory management system with 32-bit logical address, 20-bit physical address, and page size of 2048. Sir, I cannot do it, sir. I think I should prepare for gate. Good stuff is there. What do you think is the answer? Why do you think it's the answer? A schedule of three database transactions T1, T2, T3 and so on. 3211 A. 32 minus 11. Why 11? 32-bit logical system. Okay, fine. Why minus 11? And page size is 11. 2048 bytes you converted into bits, 11 bits, 2048 log. We go to ChatGPT. Explain. Okay, log base 2. Oh, nice. Is calculator allowed for gate? I think so, right? How would you calculate log? Oh, did you calculate it with calculator? Virtual cal. Okay, nice. Awesome. You're doing good. Good so far. A schedule of three database transactions T1, T2, T3 is shown. Denote read and write of data item A by transaction. The transaction T1 aborts at end. What are, which other transaction will be required to be rolled back? Holy shit. You didn't get to DBMS yet. Wow, you have exam tomorrow. You didn't get to DBMS yet. Interesting. What are your resources? Gate smashers, huh? Gate smashers operating system. Ah! Okay, audio won't come. Miso. Interesting. Claude. Which Claude? Anthropic Claude. Will there be all algorithms to do? Okay. Identify one correct matching between OSI layer and their corresponding functionalities. network layer, packet routing, transport layer. Wait a minute. Data link layer, framing, transport layer, host to host communication, network layer, packet routing. So it's A1, B3, and C2. Am I right? 16. Yeah, let's go. G is a function of A to B, F is a function of B to C, and their composition is defined as f of G is a mapping from A to C if f and f of G are on two surjective functions, which one of the following is true about function G. Holy shit. Okay, nice. This is something we like. Let G be any undirected graph with positive edge weights and T be a minimum spanning tree of G. Okay. For any two vertices UV, let D1 and D2 be the shortest distance between U and V in G and T respectively. Which one of the options is true? Holy shit, my brain. Hats off to you, sir. What is G? G is an undirected graph, yes, sir. So T is minimum spanning tree. Okay, I get it. Okay, respectively. So D1 is the shortest path between shortest path between two edges in G, and the same edges the shortest path in T is D2. Which one of the following is correct? So minimum spanning tree is we remove the edges to make the graph, uh, so it's like we remove the edges, but it's also possible to traverse to all edges. So we maintain the minimum number of edges, right? So distance would definitely increase. So uh, I think B would be the answer, because for G it might be equal if the edge is not removed. If the edge is removed, you have to travel longer. So minimum spanning tree, shortest path will be more. So 18B. Yeah, boy, let's go. I can do gate. I can do gate. Wow. But time won't be sufficient. Zero gate prep. I think there is negative marking. I think so. There is negative marking, right? Format gate exam format. Okay. 3 hours, 100 marks, 15 marks, 85 marks objective, negative marking only for MCQs. Okay, only single choice for 2 mark questions. Okay, we are answering 1 mark questions right now. Minus 0.66 for 2 marks. Holy shit. Okay, you want me to continue or you'll study? That's why I'm off to do TBMS now. Yeah, do. All the best, brother. Thanks for coming by. Okay, we'll do this. We'll do this one last thing. I don't know, master slave. I forgot master slave. You remember a master slave? My camera gone. Yes, but oh, you remember the master slave algorithm? Okay, awesome, nice grind, man. All the best. Do well. B plus 3 notes. Holy shit. Wow. Damn. Nice, nice. My beja fry just for these 5 questions, 5 to 6 questions. Okay, I get back to this. Holy shit. So I was thinking of a stack. So when I encounter the top of the stack being B, if I encounter A, I should either remove B or A. So what do I remove? I can remove either B or A.
Hmm.
If it is, if I find more A's on the right, then it's better to be remove B. In this case, if I find more B's around me, bro is grinding for Kate. We just did some questions. Wish wish him best of luck, Rupak. He has Kate exam tomorrow. He didn't start DBMS yet. Tomorrow. Yeah, he did. He's answering pretty good in OS. P A P P. They won't ask definitions in gate. What the heck? Greedy question. Maybe the constraints are very high. So yeah, greedy only. But what would you do? You need minimum. How can you find minimum? You can remove B or A. I'm guessing stack or sliding window. Sliding window, but how would we implement sliding window? Like what? How do we find count A's or B's? I guess. Okay, I count A. I count A. Two, one, two, two. Okay. B count is greater here. When it is greater, but then it becomes equal here. Again, B count is increasing. So it's better to remove A's. But the position matters. That's the problem. So it's not like removing which one. I got fried doing this gate. Same, same. We'll ask Rupak these questions. Let's see. Uh, okay, I think this is good. We'll ask each subject one question. Now starting with DSA. I'll give Infosys SP engineering questions. Wait, okay, give. But before that, which of the following statements is or true for any binary search tree having n distinct integers? The max length of a path from the root node to any other node is n minus 1. Okay. An in-order traversal will always produce sorted sequence of elements. Okay. Okay, this is multiple options. Finding an element takes time for the worst case. Every BST is also a min heap. Easy question, Rupak. A. Okay, that's it. You lost 0.66. The answer is AB. Let's see. Question 26. AB. You lost 0.66. You are in minus 6.66. Very bad. Multiple options. Okay, next question. Holy shit. You can do this, huh? um, Probability. Will you do probability? Ah, these are those questions. Okay, go to advanced VL. What do you mean VLSI? There's no VLSI here. No, that was operating system related something. D, probably D, yes. Answer this, Rupak. Easy. Nice. You did not do DSA. Yeah, yeah, B. Nice. Correct answer. Okay, answer this. Single. Which one? No idea about that subject. Operating systems. No, compiler design. My bad. This. Yeah. Back to this question. Give me Infosys questions. Meanwhile, yes. need to find for every index the number of b's before it, number of a's after it. Okay, stupid prefix some problem. For ND index, find number of b's before it and number of a's after it. Number of b's before it and number of a's after it is 0, 0, 0, 1, 1, 2, 3, 3, 3, 1, 2, 3, 0, 0, 0, 1, 1, 2, 3, 3. Number of A's after it. Number of A's are 1. A's after it. 0, 1, 1, 1, 1, 2, 2, 3. Holy shit. One comma 1 comma 2 comma 3 comma 3, and then a comma a comma b comma a comma b comma. Number of a's after it is 0, 0, 1, 1, 1, 2, 2, 3. Okay. Number of A's after this are 3. Number of B's before it are 1. Number of A's after it are 1. And number of B's after it. So if I find A and find B before it, number of B's are 3. Remove this. Okay, wait a minute. B comma B comma A comma A comma A comma B comma B comma B A. Number of B's before it. Number of A's after it. 1, 2, 3, 4. 4 comma 4 comma 3 comma 2 comma 1 comma 0 comma 0 comma 0 comma 0. Okay, so what you are saying is no luck, guys. Dynamic programming. Senior. Sure. Stupid Leetcode. Let's take hint 2 also. You can speed up by the findings of A and B in surface prefix processing. Okay. Yeah, I found out suffix and prefix. What to do? The number of p's before it are 1 and number of a's after it are 0. The number of p's before it is 0. The number of a's are 2.
Guys, no clue.
Let's go to editorial. So balance string has all A characters appearing before all B characters. A balance string can be viewed as having a boundary point where all A's are to the left. 4 2 2 2 2 3 3 4 5 5 2 4 3 2 2 2. Okay, it is like a sliding window but prefix optimization. So it was a sliding window of counting number of p's and then sliding, uh, compressing the window counting a's. So 1 2 3 4, I have 4 b's on the right. How many a's am I counting now? I'm counting 1 2. Now I remove b. The number of a's are 2. Can't find the question. Lol. 2, and the number of b's are 3. 3 6. But those are not something we remove, right? Why are we removing? Stupid intuition. Really stupid intuition. Don't get it at all. I should have done TP. Let's try TP. But how do we make sure? Okay, here it's 2. Here the count is increasing. Oh, we are not updating the answer. We are only updating the answer later. Okay. Okay, we'll do something like this. So, in count is equals to 0, count p is equals to 0, and the answer is equals to 0. If s of I is equals to b, then b plus plus count b plus plus. Now if I find b else, the answer would be min of answer comma count b return answer. Now count b is 0, count b is 0, count b is 1. Now the answer must be no, we just increment the b. Now if we encounter a again, so the answer must be removal. So count b. Oh wait, we encountered b again. 2, 3. So the minimum to remove would be either 3 is or 1. But the answer was previously 1. Now it must be 2. So plus 1. Okay. Tough intuition. Very tough. Good problem. But prefix. Stupid prefix sums. What shall we do, guys? It's been an hour already. take like 2 minute break and be back at 12 and try to complete as many questions as possible. BRB in 1 minute. Okay. You are given a zero indexed 2D matrix grid of size m into n where r he represents zero water cell containing fish. If fisher can start at any water cell and can do the operation catch all the fish and don't move to near giant cell. I don't know fish the fish and if he chooses to oh, okay max. It's like finding the uh, islands basically. So here we have holy shit. Okay, let's take this. So he cannot go on to land, so he has to start somewhere, and he can collect all the fishes in that particular area. So that will be, it's like an island problem. So uh, we can start DFS or BFS, whatever. Uh, what should we choose? Which would be better? BFS would be better than the summation. Yeah, either way we are accounting for, either way we are taking the space complexity. So iterate through the array, and if you so it's like pseudocode will be int answer is equals to 0, and then for I 0 to m, for j 0 to n, if grid of ij greater than 0, and if it is not visited, then you perform a fishes is equals to let's take tf j viz and grid answer is equals to max of answer comma fishes, return answer. So this would be the solution. So let's code the same thing up. For int I is equals to 0, um, int m is equals to grid dot size, int n is equals to grid or 0 dot size, and then less than m I plus plus. We need a visitor. I forgot about visitor. Vector, vector, comma, vector int n comma 0, and then if grade of I j greater than 0, and if it is not visited, then we go gather the fishes ij viz comma grid, and then answer is equals to max of answer comma fishes. I'll let you know. I might have to pick up my sister probably. um in dfs intro comma call comma vector vector int visitor vector int grid. I'll take r and c2, int r is equals to minus 0 1 0, and c is equals to 0 1 0 minus 1, and then comma c visited of row comma call is equals to 1 for int I is equals to 1 is equals to 0 I less than 4 I plus plus fishes is equals to new row is equals to row plus r of I new call is equals to call plus c of I if is valid of row comma call comma grid and not visited of comma call new call new row new call fishes is equals to dfs of new row new call. Let's go. Nice. 11 minutes. Can do better. You are given mn2 n binary matrix where z represents a C cell and 1 represents land cell. A move consists of walking from land cell to another adjacent land cell or walking off the boundary. Return the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. Okay. Enclosed by zeros. Have boundaries of zeros. So I can walk on land. Land is one. I can go to other land cell or walk off the boundary. I have to return a number of land cells. So it's not like an island, so it's just one land cell, etc. The number of land cells that for which I cannot walk off the boundary. So this is something I can walk off the boundary. Okay, if it were something like this, then it would. Okay, so if it zero, so for this, I think I would process all the edges and add and perform BFS on them. So if I find one, I add them into the queue and everything. At the end, I can modify this array to perform as a BFS uh, to make sure it acts as a bizrate array, but I can take a copy basically and modify this to 0. The worst case would be m into n. The worst time complexity would be m into n. Yeah. So perform BFS, check leftover, count, return, count and return leftover once. This is the algorithm, guys. So doing something internal request to grid dot size, internal request to grid of 0 dot size, int I is equals to 0, I less than m, I plus plus. Since it's going row wise now, I'll just take, first I have to take the queue of pair pair in comma int and then q dot push of row would be 0, column would be 0, row would be row would be I, column would be 0, row would be I, column would be the rightmost one. Do the same thing here, except it's n, and this must be 0. It will go column wise. This is I. This must be n minus 1, n minus 1, and then we do a BFS. We can take a copy grid 1 is equals to grid, and then BFS Q comma grid 1, and then count the leftover ones. I is equals to 0, I less than m, I plus plus, and j is equals to 0, j less than m, j plus plus, and answer is equals to 0 if grid 1 of I j is equals to 1, then answer plus plus return answer. Now we are going to write the BFS Q pair in comma in, and then while not q dot empty row is equals to q dot friend dot first, and call is equals to q dot friend dot second, q dot pop, and we put the grid of row comma call as 0 and iterate in 4 directions. Int r is equals to minus 1 0 1 0, c would be 0 1 0 minus 1 is equals to 0, I less than 4, I plus plus, new row is equals to row plus r of I, new call is equals to call plus e of I. If is valid of new row new call grid, then we push it to the stack new row comma sorry q, what the heck. Now I'll write p is valid int I int j vector grid j greater than equal to 0 with sort size grid of 0 dot size and grid of ij equal to 1. Remove if it is only 1. Wrong answer. Rid of I command minus 1 equal to 1. If rid of I command minus 1 equal to 1, I comma 0. If rid of n minus 1 I equal to 1. TLE TLE. Okay, instead of iterating, what if I damn. I understood the problem. There are n cities numbered the 0 to n minus 1 given the array edges where edge of I from to weight represents a bidirectional and bidirectional, okay, directed, undirected, and weighted edge from and to, and given the integer distance, return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. If there are multiple such cities, return the city with the greatest number. Notice that the distance of the path connector is return the city with the smallest number of cities that are reachable through some path. And okay, we have this graph and hmm, the neighboring cities at distance threshold is 4 for each city. So for city 0, I can reach city 1 and city 2. For city 1, I can reach city 0, city 2, city 3. For city 2, I can reach city 0, city 1, city 3, and city 3 I can reach city 1, city 2. Okay. Mm. Is it all pair shortest path? like all pairs shortest path. Yeah, all pair shortest path. We have Floyd Warshall and I forgot another. All pair shortest path algorithms. We have Floyd Warshall and what is the other one? Okay, so my approach is like convert this into adjacency matrix. So it would look something like of n into n. So n into n matrix and so 0 0 would be 0 0 1 is 3 and 0 2 is unreachable right now. So it must be infinity and then 0 to 3 is also infinity and then 1 to 0 is 3, 1 to 1 is 2, 1. Let's take infinity as I 1 to 3 is 4 and then 2 to 0 is infinity, 2 to 1 is 1, 2 to 2 is 0, 2 to 3 is 1, 3 to 0 is infinity, 3 to 1 is 4, 3 to 2 is 1, 0. So we are doing Floyd-Warshall algorithm. So it's like um, take a node, take something as your intermediary node and find the you need to loop it n minus 1 times. You need to perform this algorithm n minus 1 times or n times n minus 1 I think and take a intermediary node. Each time you have to take an intermediary node, or is it each time? Yeah, you'll take an intermediary node and then it's like dp of ij is equals to r. Yeah, uh, min of dp of ij comma dp of I to k and then TP of K to J. Grid, grid, or DP, whatever. Grid, grid. So taking the intermediate tree node as 0, if I want to go from 0 to 0, the minimum is 0. But if I want to go from 0 to 1 as 0 as my intermediate tree node, I have to go from 0 to 0 and 0 to 1. The minimum would be 3. Okay, fine. If I want to go to 0 to 2 with 0 as my intermediary node, okay, stupid. Let's take 1. Now in the next iteration, if I want to go to 0, 0 to 1 with 1 as my intermediary node, uh, I should go from 0 to 0 and 0 to 1. If I want to go to, uh, let's take 1. Let's take, if I want to go to 0 to 3 with 1 as my intermediary node, 0 to 3 with 1 as my 0 to 3, I can directly go, or I can choose a path via 1. So, oh yeah, so it's like int k is equals to 0, k less than n, k plus plus, and then if I want to go to, I'm confused whether it's like I have to iterate it like taking intermediary node and traversing it the entire way, or for each row and index traversing via. If I want to go to 0 to 1 via 0, what's the shortest path? If I want to go to the shortest path, if I want, okay, let's find out. I'll convert this into uh, adjacency matrix size n into n with infinite with the max value is um, 10 power 4, let's say 29, and then I'll traverse to the edges auto I edges q is equals to I of 0 and v is equals to I of 1 and weight is equals to I of 2 adjacence of 0 to 0, 0 to 0 is equals to 0, adjacence of v to v equals to 0, and then adjacent of u to v is equals to weight. Adjacency of v to u is equals to weight, and then we take 0 to 2. Okay, we'll do that later. K is equals to 0, k less than n, k plus plus for int I is equals to 0, I less than card, n I plus plus int j is equals to 0, j less than n, j plus plus t2e. Grid of I j is equals to min of grid I j comma grid of I k plus grid of k j. Now after everything is done, I'll traverse through the array I plus plus j less than n, j plus plus 0 to 1, it's 3. 0 to 2, I have 4 as my shortest path. 0 to 3, I have 5 as my shortest path. 1 to 0 is 3, 1 to 1 is 0, 1 to 2 is 1, 1 to 3 is 2, 2 to 0 is 4, 2 to 1 is 1, 2 to 2 is 0, 2 to 3 is 1, 3 to 0 is 1 to 5, 3 to 1 is 2, 3 to 2 is 1. Okay. Imensities is equals to n, and the answer is equals to 0 if cities less than equal to the threshold. Distance threshold cities plus plus rid of ij. Cities is less than min cities less than equal to the min cities, then min cities is equals to cities, then answer is equals to I. Return answer. This is adjacent, 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 Wait a minute. Wait a minute. Wow. Crazy. Bellman Food. Shortest path first algorithm. Floyd Warshall is the cleanest among all. Like n cube and n square. N power 4 and n square. N power 4 and n square. N cube log n. Awesome. Okay, let's see what happens if I put this here. Will it fail? Yeah, it is failing. At each intermediary node, I think it will be interesting for this part or this part. 3, I can go via 3 or via 2. 1 to 3, the shortest path is like 2 plus 3 to 6. Oh, interesting, nice. Done, guys. We've done 3 problems. We gotta do 2 more for today. Let's see. 'We'll take a 5-minute break and come back, guys, for this session. For the next 1 hour, 1 to 2, we'll complete these 3 questions. They are tough.